Picture two identical electric vehicles pulling up to the exact same charging station. Same cable, same weather. The first car finishes its charge and drives off in just 18 minutes. The second car sits there waiting, 40 minutes later. It isn't a faulty charger. It isn't a broken cable. The difference comes down to a single number buried deep in the spec sheet, a metric almost nobody checks before buying a car.
Charging an EV isn't like filling up a gas tank. You are literally pushing electrical energy, measured in kilowatts, into thousands of individual battery cells. And the speed of that push relies on one fundamental equation every single automotive engineer has memorized. Power equals voltage times current. It really is that simple. If you want to charge the vehicle faster, you need to deliver more power. Mathematically, you only have two possible paths to get that extra power. You can either raise the voltage, or you can raise the current.
For over 10 years, the automotive industry took the exact same predictable path. They pushed more current. The logic was obvious: pump in more amps, get more power, achieve faster charging times.
That current comes with a massive penalty. Pushing high amps generates extreme heat, and heat acts as the ultimate enemy to every wire, every connector, and every delicate battery cell inside that vehicle.
To stop the cars from melting down, engineers had to fight that heat with brute force. They added thicker copper wiring, much heavier cables, and massive, complex cooling systems.
All those extra components added up. The fastest charging electrical systems inherently became the absolute heaviest and most expensive ones to manufacture. There was a second lever on that equation the entire time, one almost nobody was pulling: raising the voltage. Here is the elegant, mathematical reality. If you simply double the voltage, you can deliver the exact same amount of power using only half the current. Cutting the current in half immediately eliminates those massive heat penalties. You can use thinner cables, you can build lighter connectors, you lose far less wasted energy to heat. It isn't a magical new battery chemistry, it's just a significantly smarter way to move electricity.
Mechanically, this requires restructuring the battery pack inside the car. Engineers wire the cells in a longer series string, raising the pack's natural voltage to around 800 volts instead of the traditional 400. And those benefits extend way beyond the charging port. Because the entire system operates at a higher voltage, the motor and the inverter handle less current too. They can be built smaller, lighter, and vastly more efficient. You strip heavy copper out of the wiring harness. You shave crucial weight right out of the drivetrain. Every single kilogram you save instantly translates into extra driving range. Or it lets automakers use a smaller, cheaper battery to do the exact same job. An 800-volt architecture doesn't just give you a faster charging car. It creates a fundamentally lighter, more efficient machine from the plug all the way to the wheels.
If it's mathematically superior in every way, you might be wondering why every car doesn't have it. Here is what the sleek marketing slides ignore. 800 volts isn't free.
Pushing that much voltage demands entirely new power electronics. Specifically, the industry has to abandon traditional silicon chips and use silicon carbide semiconductors. It is the only material tough enough to handle the intense voltage stress without physically breaking down. Those silicon carbide chips are incredibly expensive to manufacture right now. Compound that with the fact that the insulation on every single high-voltage wire must be upgraded, and the entire battery management system must be redesigned from scratch. Hard truth, that massive cost premium is exactly why automakers simply stayed at 400 volts for standard, everyday vehicles. The older tech is cheaper, it's proven, it works perfectly fine for normal driving. This leaves us with an uncomfortable truth hiding beneath modern price tags. The ultra-fast charging future is already here, but it's locked behind a premium paywall. For every single vehicle built on that older 400-volt standard, that 18-minute charge simply isn't possible. It doesn't matter how incredibly powerful the charging station outside the car is.
What does this actually mean for you the next time you're standing in a dealership looking at an electric vehicle? Stop asking the salesperson how many kilowatts the car can accept. Start asking them for the native pack voltage, because an 800-volt vehicle will beat a 400-volt vehicle on the exact same charger every single time.
Right now, you'll mostly find these 800-volt systems hiding in luxury and high-performance models, but the long-term direction is totally clear. As those silicon carbide chips get cheaper to produce, this advanced architecture will rapidly shift down market. Within a few short years, it won't be a luxury checkbox anymore. It will be the new industry baseline.
Same charger, same cable, same 18-minute charge time versus 40. Except now, you know exactly why. And as 800 volts becomes the standard for everyone, it leaves us with one massive question. What invisible engineering bottleneck will the industry have to conquer next?